Good morning, students. Today we will learn about the next topic of Unit 3, that is encryption, decryption, and cryptography. First, let us see the different topics that would be covered in this video. The topics that would be covered would be cryptography, encryption and decryption, message digest, digital signatures, and digital certificates. Next, first let us see what is cryptography. Cryptography can be defined as the art or science encompassing the principles and methods of transforming an intelligible message into one that is unintelligible and then retransforming that message back to its original form. Nowadays, when you send a message or a data from one computer to another computer, that data becomes susceptible to different problems. That is, unauthorized people could modify or forge your data either for amusement or for their own benefit. So cryptography is nothing but a process of transforming the data or the message at the sender's end and then retransforming it at the receiver's end. Cryptography consists of two things, encryption and decryption. A message sent over the network is transformed into an unrecognizable encrypted message known as data encryption. At the receiver's end, the received message is converted back to its original form known as data decryption. Now let us see what is encryption. Encryption is nothing but transforming your original data into a form that is not understandable to anyone except the sender and intended receiver. Encryption is a process which transforms the original information into an unrecognizable form. This new form of the message is entirely different from the original message. Encryption is the process of transforming information referred to as plain text using an algorithm called cipher to make it unreadable to anyone except those possessing special knowledge, which is referred to as a key. The result of the process is encrypted information referred to as ciphertext. Before going ahead with the decryption topic, first let me tell you about these terms that we have used in this encryption process, that is plain text, cipher, ciphertext, and key. In the slide, you can see that this encryption process is depicted. That plain text is converted into ciphertext using keys and algorithm. What is a plain text? The original message that is easily readable by humans. It is a term used in cryptography that refers to a message before encryption or after decryption. For example, if a person A wishes to send a message to a person B, that is, hello friend, how are you? Here, hello friend, how are you is a plain text message that is intended to be sent via a communication network. Next, ciphertext. In cryptography, ciphertext is data that has been encrypted. This text is unreadable until it has been converted into plain text with a key. Next, what is cipher? Cipher an algorithm for transforming an intelligible message into that is unintelligible by transposition or substitution methods. Next, what is key? In cryptography, a key is a string of characters used within an encryption algorithm for altering data so that it appears random. Like a physical key, it locks or encrypts your data so that only someone with the right key can unlock or decrypt it. Encipher or to encode means the process of converting plain text to ciphertext using cipher and a key. Decipher or decode means the process of converting your ciphertext back into the plain text using again a cipher and a key. Let me explain you this with an example. In this, you can see that the message that a sender wants to send to a receiver is I love apples. So I love apples is a plain text. The algorithm or the logic or the cipher behind this message is to replace it with a successive letter. So the key here is to replace it with every third successive letter. So here is the key. The cipher or the algorithm here is to replace it with a successive letter. Once you replace every letter with the third successive letter, the resulting message that you get, which is not in an understandable form, is known as ciphertext. So I love apples was a plain text. The text highlighted in green color is the ciphertext. Cipher or the algorithm is to replace every letter with a successive letter. And finally, here the key is 3, which means that every letter would be converted into a successive letter, which is at a third position in the alphabet sequence. Next, let us see what is decryption. Decryption is a process of converting encoded or the encrypted data back into a form that is readable and understood by a human or a computer. Decryption happens at receiver's end, where the receiver tries to decode the message sent by the sender. This method is performed by unencrypting the text manually or by using keys to encrypt the original data. In other words, it is a process of taking your encoded text and convert it back into original text. Cryptography uses the decryption technique at the receiver side to obtain the original message from the non-readable message. In decryption also you use two things, that is an algorithm and a key. So as you have used an algorithm and a key at the encryption, you use the similar technique to decrypt your message via an algorithm and a key. So when you use different keys, there are different type of cryptography that emerges, which we will see in the next slide. In this figure, we are seeing the decryption process in which the ciphertext is converted into plain text using a key and algorithm. Now, what are the different types of cryptography on the basis of different type of keys? Type of cryptography. The key used at the time of encryption works on the plain text, and at the time of decryption works on the ciphertext. The selection of key plays a vital role in cryptography process, as the security of encryption algorithm fully depends upon it. As I've already explained you in the previous example, with giving you another example, if A uses a key of 2 to encrypt a plain text university, in this it means that every letter in the word university would be replaced with the second successive letter in the alphabet sequence. So you would come to a ciphertext which does not mean anything to anybody. So the key here is 2. Now there are two types of cryptography based on different keys. First is symmetric key cryptography. Second is asymmetric key cryptography. Symmetric key cryptography uses the same key. That is, for both encryption of the plain text and decryption of the ciphertext, you use the same private key. It is a key that is used at the both ends by the both parties, that is the sender and the receiver. So the sender and the receiver should know the key beforehand, before the communication. So it is known as private key, which is a secret but is known to both the parties that are trying to communicate. Next is asymmetric key cryptography, which uses two pair of key for encryption. Public key is available to anyone, while the secret key or the private key is only made available to the receiver of the message. This type of cryptography boosts security. How this asymmetric key cryptography works would be explained in the further video. First, let me explain you what are the different type of keys in asymmetric key cryptography. First is public key. As we have already known that in asymmetric key cryptography we use a pair of keys, that is we have two keys that are working. So the public key that is used to encrypt message by a sender to be received by a receiver. Private key is a key that is used to decrypt messages received by a receiver from a sender. So I'll explain you this again. So what happens is, when you as a sender wants to send a message to another person who is the receiver. So what you do is you use the public key of that particular receiver and encrypt your message. But that message would only be decrypted by the private key of that particular receiver, which is private to the receiver and would only be available to him or her. So the private key would help the receiver to decrypt this message. So public and the private key are linked together. One public key is only related to one private key. If I have encrypted or changed my message into an unreadable form using a public key of a receiver, that receiver can only decode that message using his private key linked to that particular public key. So this is how asymmetric key cryptography works. Pre-shared key in cryptography is a shared secret which was earlier shared between the two parties using a secure channel before it is used. Now let us see what is symmetric key cryptography. This is the simplest kind of encryption that involves only one secret key to cipher and decipher the information. Symmetrical encryption is an old and a best known technique. It uses a secret key that can either be a number, a word, or a string of random letters, which is blended with the plain text of a message to change the content in a particular way. The sender and the recipient should know the secret key so that they could encrypt and decrypt all the message that they want to send. In symmetric key cryptography, same key is shared. That is, the same key is used for both the process of encryption and decryption. The algorithm used to decrypt is just the inverse of the algorithm used for encryption. For example, if addition and division is used for encryption of some type of text, then multiplication and subtraction are used to decrypt that text. Symmetric key cryptography algorithms are simple, requiring lesser execution time. As a consequence, these are commonly used for long messages. However, these algorithms suffer from one limitation, that is, it requires a large number of unique keys because you are using the same key to send a message via encryption and using the same key to decrypt it. So while you are communicating with different people, you need to change your key while communicating with different receivers. So once you change the receiver, you need to change the key. So it requires a large number of unique keys. Now let us see what is asymmetric key cryptography. Asymmetric cryptography is also known as public key cryptography, which is relatively a new method compared to symmetric cryptography. Asymmetric cryptography uses two keys to encrypt and decrypt your message. It is important to note that in symmetric cryptography, anyone with a secret key can decrypt your message, and this is why asymmetric cryptography uses two related keys to boost the security. A public key is made freely available to anyone who wants to send a message to you. So what is happening is, in this type of cryptography, you have two keys. One is a public key, another is a private key. The public key is announced to the public and the private key is kept by the receiver. So if I am the receiver and I want to receive a message through a sender, so I will announce my public key to anyone. That particular sender will encrypt his or her message via using my public key. And once it has been received to me, I will decrypt that message using the private key which was only known to me. So the public and the private key are linked together, and one public key is related to only one private key. So if my public key has encrypted a message, only my private key can decrypt it. So this is how asymmetric key cryptography boosts security. Security of the public key is not required because it is publicly available and can be passed over the internet. But as we know that private keys only is private only to the receiver, so it enhances the security. Asymmetric key has a far better power in ensuring the security of information transmitted during the communication. Now let me explain you public key or asymmetric cryptography with the help of an example. A person named Alice generates a key value which she makes public. So basically she is generating a public key and is making it public and letting be known to everyone. Alice uses her public key to determine a second key known as private key, which is only known to her. Alice keeps her private key secret. Now Bob or anyone else, any person can use Alice's public key to encrypt a message for Alice. So Bob wants to send a message to Alice via internet and want it to be secure. So what would Bob do is that Bob would use the Alice public key to encrypt a message that only Alice could read. Alice can use her private key to decrypt that message. No one without access to the Alice private key can easily decrypt that message because the private and the public key are also linked together. So one public key can be used to encrypt a message and the corresponding private key can only use to decrypt that message. This diagram depicts the public key cryptography. Here it is shown that Bob uses Alice's public key to encrypt a message and then sends it to Alice, which she decrypts using her private key. Next, we'll see an example of internet commerce. Bob wants to use his credit card to buy some brownies from Alice over the internet. Alice sends her public key to Bob. Bob used this public key to encrypt his credit card number and sends the encrypted number to Alice. Alice now uses her private key to decrypt the message and would get the credit card number of Bob. So this is how public key cryptography works. Next, we would see what is message digest. Message digest is a way to verify the contents of the message that you are receiving on the internet. What is message digest? It is a fixed size numeric representation of the contents of a message computed by a hash function. Most of the messages that you send over internet are inherently variable in size. So a hash function applied on a message that is of various converts that message into a message digest which is of fixed size. A message digest is computed by a hash function and the hash function should follow two criteria. The hash function must be one way. It must not be possible to reverse the function to find a message corresponding to a particular message digest. It must be computationally infeasible to find two messages that hash to the same digest. So how do we send this message digest? The message digest is sent with the message itself. Receiver can generate a digest from the message that he has received using the hash function, and after that could compare both the digest that the sender send the receiver and the digest that receiver has generated on his own. The integrity of the message is verified when the two message digests are same. Any tampering with the message during the transmission almost certainly results in different message digests, and hence you can know that some tampering has happened with your message if both the digests are not matching. Now let us see what are digital signatures, that is, how do we sign a document digitally. A digital signature is a mathematical technique used to validate the authenticity and integrity of a message, software, or a digital document. As the digital equivalent of a handwritten signature or stamped seal, a digital signature offers far more inherent security, and it is intended to solve the problem of tampering and impersonation in digital communication, which are basically a big problem while communicating digitally. So this digital signatures solve that problem. Digital signatures are based on public key cryptography, which uses two keys, a private key and a public key. Now, how this works? To digital signatures, we also need message digest. Once you have created a message digest of your message, that is, you have converted your message into a fixed size message, you encrypt that message digest to create digital signature. Now, how this works? The sender who is sending the message will encrypt that message using his or her private key. Not the public key of the receiver, but using his or her private key. Now these messages can then be decrypted by anyone who possesses sender's public key. And also we know that each public key has only one matching secret key. If a particular public key has been used to decrypt a messages, so we can be assured that the matching secret key was used to encrypt it. And this is how digital signature works, and this is how the receiver knows that the message was sent by a particular person who encrypted it using his private key, which he only knows about. So this is how our identity is known when we use digital signatures and send a message. Now let us take an example of digital signature. Now again we'll see how Alice and Bob communicates over internet using digital signature. Alice applies a publicly known hash function to a message that she wishes to sign. Now what is happening, that hash function is known to everybody, so Bob also knows that hash function. Now this function produces a digest of the document. Now Alice, using her private key, encrypts this digest. So you are sending the message as well as the message digest that is encrypted via private key to Bob. Now Bob, once has received this encrypted message, now uses Alice's public key to decrypt the digest, and he also has received the message. So what happens is Bob uses the hash function on the message received from the Alice, and he also decrypts the message digest that Alice sent him by encrypting using her private key. Now Bob would check the message that he has converted using hash function and the decrypted message, and if both the values of the digest are same, if they match, it proves that Alice signed the document and that no one else has altered it. Now let us see how we can transmit securely the digital signed documents over internet. This would be explained via using a diagram. Now let us see this with an example. Alice wants to send a message to Bob. She has plain text, which is the message she wants to send. She passes that plain text through hash function and creates a digest. That digest is again encrypted using her private key to make out a digital signature. Also, that plain text is encrypted using Bob's public key to get a ciphertext. This ciphertext plus the digital signature are sent to Bob via internet. Once Bob has received this message, he would decrypt that message using his private key to take out a plain text. Also, the digital signature attached to it would be decrypted using Alice's public key to get the digest that she created. The Bob now would pass that plain text to hash function. Hash function would create a digest. Bob would now compare both the digests. If both the digests are same and are matching, that means the message is authentic and was not tampered in the communication media. Lastly, we will see what are digital certificate. An electronic document issued by a certifying authority to establish a merchant's identity. Digital certificate is used by a trusted third party which proves sender's identity to the receiver and receiver's identity to the sender. A digital certificate is a certificate issued by a certificate authority to verify the identity of the certificate holder. The certificate authority issues an encrypted digital certificate containing the applicant's public key and a variety of other identification information. Digital certificate is used to attach public key with a particular individual or an identity. So this was all about encryption and decryption. Thank you so much, students.